Today on Under the Big Tree, the history, philosophy, and application of the Serge Modular Synthesizer. Hi there, and welcome to this presentation on the Serge Modular Synthesizer. For those who are not familiar with the modular synthesizers originated by Serge Cherepnin, they've been around in various forms since the early 70s, and have really enjoyed a resurgence in popularity in the last few years. I'll talk today about the history of Serge synthesizers, primarily within the design philosophy behind this lovely instrument. I'll go into what makes a Serge different from other modulars, and we will talk about some of the truly original and key modules, such as the dual universal slope generator. We'll take a look at the primary design iterations the Serge has undergone over the past 50 years, and touch on some of the manufacturers that are making Serge modules in various forms today. Finally, we'll take a look at Euroserge, which, as you might guess, is Serge modules scaled down to a Eurorack form factor. So let's start with the history lesson. The Serge is named after the inventor, a composer and teacher of Chinese-Russian descent named Serge Cherepnin. Serge was born in 1941. A graduate of Harvard, he studied composition with such luminaries as Nadia Boulanger, Karlheinz Stockhausen, and Pierre Boulez. Serge became an American citizen in 1960, and by the early 70s was teaching at Cal Arts in Santa Clarita, California, under Morton Subotnick. It was there that he was first exposed to the Buchla modular. At that time, the only choices were Buchla and Moog modulars, which were, and continue to be, beyond what most avant-garde composers or students could afford. Serge wanted to rectify that problem and decided to create the people's synthesizer. He worked with students Rich Gold, Randy Cohen, and Rex Probe to develop a series of modules that could massively cut down on production costs by making them available as DIY kits. Serge built the first 20 systems at home, then made the kits available. For $700, composers could buy all the materials needed to make a robust, full-featured modular synth with good electrical design and high-quality parts. Students learned how to solder, and an ad hoc production line began in the stairwells of Cal Arts. This all began in late 1972. Right out of the gate, all of the basics were there. A wave-shaping oscillator, a filter that was simultaneously high-pass, bandpass, and low-pass, an envelope generator, a VCA, a ring modulator, mixers for audio and control voltages, and positive and negative slew modules. The focus on value, practicality, and customization led to some particularly brilliant design decisions. A single panel of Serge modules would be 17 inches by 7 inches and would fit handily into a standard equipment rack. The front panel consisted of a piece of metal with a matrix of 16 or 17 by 6 holes pre-drilled into it. You would choose the modules you wanted to build and the order you wanted to place them in the panel. A very logical design vocabulary for the front panel emerged that reminds me somewhat of Egyptian hieroglyphics. You could take the designs for your particular modules, apply them to a piece of paper, and then glue the paper down onto the front panel. You could, of course, make your own design, apply a piece of art, or do anything else you wanted to. Pre-drilled holes that were not filled by a banana jack or potentiometer were covered over by the paper, and this is why the first generation of Serge modules are called Paperface. This was an ingenious design decision that fit right into the maverick DIY spirit of the people's synthesizer. By 1974, Serge left Cal Arts to focus on selling his kits commercially and to continue to develop and improve the line of modules. He rented a space on Western Avenue in Hollywood, just north of Santa Monica Boulevard. This is where much of the development took place as the range of modules became more sophisticated. The second generation of modules were developed between 1974 and 1975. Then, in 1976, the third generation of modules were born. These include some of the most well-known Serge-specific modules, such as the dual universal slope generator, the new timbral oscillator, and the touch-activated keyboard sequencer, or TKB. If you've ever used the Make Noise Maths or the Bufacco Rampage, then you can thank the dual universal slope generator, without which those modules would not exist. This was also the point where the hieroglyphic-style panel design was replaced by a clearer, more utilitarian graphical layout over aluminum. A fourth generation of modules appeared in 1979, and in 1980, Serge moved the factory to my hometown of San Francisco, to a 3-story Victorian on Haight Street. The rise of mass-market digital synths in the 80s really hurt the viability of smaller companies making analog synths. Eventually, Serge closed up shop. He switched to a licensing model and sold the remainder of his materials to Rex Probe, a former CalArts student who created an Oakland-based company called Sound Transform Systems. Probe was not involved in DIY sales, but instead built and sold finished panels in various configurations, which he still does to this day. In 1986, after closing his company, Serge returned to France, where he focused on other interests and licensed his circuits to a variety of other companies. Some 32 years later, in 2018, Random Source, a Berlin-based company, announced that Serge was working with them and took the title of Chief Innovation Officer. With the explosion of activity in modular synthesis, vintage synthesizers, and analog circuitry, interest in Serge synthesizers is perhaps greater than it has ever been, which is a wonderful happy ending to this story. Serge's creations are now used and appreciated by several generations of electronic musicians, and he is finally getting the recognition he deserves once again. I first came in contact with Serge Modulars in 1991 at San Francisco State University. I was doing my undergraduate work in electronic music there while rocking a killer mullet, and they had a simple but highly functional studio that I practically lived in. We were taught the basics of synthesis on a modest Buchla 100 from the late 60s that had been used by countless students. But on the other wall was a much more complex and comprehensive modular synthesizer. It was big, daunting, and extremely powerful. I seem to remember that we got some rudimentary training on the system, but it was truly up to the student to explore, learn on their own, and make music on this strange and colorful device. It was an 80s-era, 9-panel Serge made by Sound Transform Systems. I remember spending every minute of studio time I could get exploring and trying to understand this beast. I always felt a personal connection to it and thought about it quite a bit, wondering what it would be like to have a Serge of my own. After I graduated, I learned that the Serge had been replaced with a Macintosh 2CI computer. The mighty Serge had suffered the fate of so many analog instruments of the time. But it ended up in the basement of Dr. Herb Biddulph, the retired electronic music professor who had championed the studio all along. He was a terrific composer, and a teacher that inspired you to actually make music with the technology. Herb is gone now, and I never found out what happened to that amazing system. Now, of course, people are looking back at these magnificent analog instruments of yore and realizing what they had. I hope that Serge made its way out of Herb's basement and is being used and cared for today. I'm pretty sure that the Mac 2CI has long since been turned into landfill, suffering the fate of the disposable digital device. There are a number of design decisions and philosophical choices that define a Serge system. The first is a tendency towards DIY. As previously mentioned, the original intention was for the People synthesizer to be sold as a kit, where electronic composers could spend a lot of time with a soldering iron and oscilloscope to be able to have a professional synthesizer at a very significant savings over a pre-built Moog or Buchla. If the DIY route is not for you, you've always been able to purchase pre-built panels, and there are a number of vendors who fill that need today. But that maverick DIY philosophy has been part of the Serge DNA since the beginning, and is still flourishing today. You can purchase Serge DIY materials from Prism Circuits, Elby Designs, Low Gain Electronics, 73 to 75, and others directly from their websites, as well as through DIY distributors like SynthCube, Modular Addict, and Thonk. Buying versus building. There are great reasons to go either way. If money is less of an issue than time, or if you do not feel comfortable wielding a soldering iron, then buying pre-built makes a lot of sense. If, however, you are willing to put your time into the creation of your instrument, you can build up a system over time at a steep discount, plus have the deeper connection to an instrument you made yourself. It makes your system that much more unique. Bear in mind that building does involve a lot of work beyond just the soldering and assembly. You have to source the components, most of which can be purchased from the major electronics suppliers like Mouser, DigiKey, and Tata. There are sometimes some hard-to-get components that take a little more effort to find. But Prism Circuits, for example, sells the hard-to-find transistors, integrated circuits, and Vactrols, which you can buy at the same time that you buy their circuit boards. And I'm always a fan of buying a full kit, which includes all the components when available. Once you build your modular panel, you still have to calibrate it and debug when the build doesn't work. Neither of these things are deal breakers, and will once again teach you more about the instruments you're working with. If you do go DIY, go slowly and methodically. You're not in a race, and if you accidentally place a component in the wrong place while rushing, you will have to debug it and figure out what went wrong. Much better to take your time, check the placement of each component as you work, and just enjoy the zen, calming solitude of the process. So to sum up, there are pros and cons to both approaches. In my case, I have an 8-panel Serge system. I bought 3 panels from Elby Designs to start, then built the 2-panel home-built kit from 73 to 75, then built 2 panels from Prism Circuits, and have a panel of individual, more modern modules such as a Turing machine, an orgone accumulator, and a Euclidean sequencer. Next up, I'm going to build a 2-panel portable Prism Circuit system optimized for improvisational live performance. Characteristics of a Serge system. Serge modules are 4U tall. As the name implies, 4U is taller than the 3U Eurorack standard and shorter than the 5U Moog or .com standard. 4U is exactly 7 inches tall, and a panel of modules is designed to fit into a 19-inch off-the-shelf equipment rack. This affords a lot of opportunities for cases that are less expensive than many designed for Eurorack. The 3U Eurorack standard is about 5 inches tall, and I find the 7 inches of a 4U module to give me much more room to navigate. It is easier to access knobs, jacks, and switches in 4U. I don't feel like I have to fight my way through a forest of patch cords to operate the instrument. 5U, on the other hand, gives a ton of room, but the modules are so large as to make them impractical for portability. To that end, I think that 4U is the perfect compromise. Just like Buchla, the Serge system uses banana jacks, as opposed to the 3.5mm mini jacks used by Eurorack or the 1/4-inch jacks used in 5U. In Buchla land, only control voltages are sent over banana cables, and audio signals are sent over tiny jacks. Tiny jacks is a format that is slightly different from standard 3.5mm jacks. These cables are uncommon and can be difficult to source quickly. In the world of Serge, signals are signals, whether audio or CV, and they are all transmitted via banana. This fits in neatly with Serge's design philosophy, in which the same modules can generate both control voltages and audio signals, depending on how they are patched. The notion is that an audio signal is merely a sped-up control voltage. Electricity is electricity. There are 4 types of signals that run through the Serge system: unipolar control voltages, triggers and gates, bipolar control voltages, and audio signals. Bipolar control voltages and audio signals are basically the same, though a typical control voltage waveform will be slower than an audio waveform. It's important to understand that you won't break anything by connecting any input to any output. You might not get interesting results is all. If a device is expecting a unipolar input and you send it a bipolar control voltage or audio signal, it just might not respond to the negative voltage portion of the signal. This is different than Buchla systems, where control voltage inputs have to see unipolar signals. So, if you are mixing Serge and Buchla circuitry together, it is important to keep that difference in mind. So getting back to banana jacks, there are some real advantages and a couple of things to be aware of as well. I can tell you that once you start working with banana jacks, you may not want to go back to Eurorack cabling. Why are banana jacks so great? Well, first of all, they make a very solid connection between the cable and the jack. You absolutely know when you have inserted or removed a banana cable, and the odds of having a scratchy, intermittent connection are low. There is so much surface area in contact between the cable tip and the jack that connections are really solid. In addition, banana jacks are stackable. You can plug a cable into either the rear or the side of another cable and then split the signal to different locations. This works for sending a signal out to multiple locations. You would not want to sum multiple signals together to a single location without a mixer. But imagine taking a CV output and routing it to multiple inputs, or sending an audio signal to multiple processors. Because of the inherent design of the banana jack, you never need a mult in a Serge system. The multing of signals is built right into the cable. The strength of the banana system is also a drawback, or at least something you have to plan for. So, what is the primary difference between a banana jack on one hand and 3.5mm or quarter-inch jacks on the other? I'm not talking about the size or form factor, but something more fundamental than that. The banana cable makes a single connection, not the two simultaneous connections those other formats do. Bananas only transmit the signal, not the ground as well. And as you know, you can't have a circuit without a path to ground. Those pesky electrons have to go somewhere. So, in the Buchla and Serge systems, the ground, or 0-volt reference signal, is derived from the power supply. Since every component in a system is sharing the same power supply, it's sharing the same ground signal. But what happens when you want to connect your banana system to another one with a different power supply, or to a Eurorack system? Now, there is no common reference, and so it won't work the way you expect. Perhaps there will be ground hum, for example. So, when using multiple systems where signal is being sent back and forth with banana cables, you have to tie their grounds together with a dedicated ground wire. Devices like the Buchla music easel have a dedicated banana jack in the side just for this purpose. The power supplies in my 8-panel Serge system have their ground inputs connected together. And I have a depth for a Eurorack case that I use with my Serge and Buchla stuff sometimes. I drilled a hole in the back of the case, inserted a banana jack, and soldered a wire inside to the ground pin of the power supply. It's no big deal, but something you have to be aware of when using bananas. As I alluded to earlier, modules in the world of Serge have a tremendous amount of flexibility, being able to generate both control signals and audio signals in many cases. The circuits are designed with components that can serve a number of purposes, being able to work at both control voltage rates and audio rates. For example, you can make an oscillator out of many Serge modules, including filters, envelope generators, and slope generators. These oscillator circuits may not track 1 volt per octave, but you can certainly use them to generate interesting sounding signals. It requires a different mindset than working with Eurorack or 5U modular systems. In those systems, you would typically use a bespoke oscillator module. In Serge systems, there are oscillator modules, but there are so many other ways to generate an audio source that a specific oscillator module is not as crucial. An early circuit called the negative slew, for example, makes a great oscillator just by patching it a certain way. Serge made a user interface design decision early on that both lowered the cost of production and made it easier to learn his modules. He standardized the position of all holes in the front panel into a regular matrix of 16 or 17 holes across by 6 or 8 holes down, and evolved a graphical vocabulary combined with specific colors for the banana jacks that made it much easier to learn new modules. All the knobs, jacks, and switches line up in neat rows, giving plenty of room to work and see the materials in an uncluttered fashion. The graphical design vocabulary followed suit, using a hieroglyphical language in the Paperface units to illustrate signal flow. Later iterations replaced the hieroglyphics with a very clear, minimal, no-nonsense labeling scheme. The point is that once you learn the language, you don't just learn how one module works, but how all of them work. Compare and contrast to Eurorack, where every manufacturer has a different design vocabulary that displays their aesthetic and sets them apart from the competition. This is great, but Eurorack is often about mixing and matching modules from a variety of manufacturers, thus requiring that you learn a variety of visual vocabularies to become proficient at your system. In addition, different Eurorack manufacturers place their jacks, switches, and knobs in different locations on the faceplate, while Serge component placement is limited to the ordered grid of holes. It makes it easier to find what you're looking for at a glance. Touching on the Paperface concept a bit more in conjunction to user interface design, the idea of creating your own graphics with this default structure already in place for you again epitomizes customization and the DIY spirit. You really can take it as far as you want, and using today's tools make customizing a Paperface panel that much easier. For example, to create a Paperface for a Prism Circuits panel, you download the graphical layout from their website for each module, then lay them out together in Photoshop or GIMP. You can print it out as is, or add additional layers of imagery as you see fit. Once you have it, you can print the layout on a couple of pieces of paper, glue them to the panel, roll them flat to remove any air bubbles, and then stick down a translucent plastic sheet on top to protect it. You punch holes in the paper where the jacks, knobs, and switches are going to be, and leave the holes that are not used simply covered by the paper. For my first panel, I created a Photoshop file of the panel graphics, then brought it to a print shop, where they printed it on a sticky, tabloid-sized sheet of glossy paper. That approach also worked fine. Moving on from user interface thoughts, let's discuss Serge's concept of patch programmability. This is what really differentiates Serge's ideas from other synth design philosophies. The notion is that each module can serve a variety of functions, depending upon how it's patched. As many signal points within the circuit as possible are exposed as banana jacks on the front panel, and so you can alter how a module works by routing connections to other inputs on the same module. For example, the smooth step generator can be an oscillator, a filter, envelope generator, lag generator, LFO, stair-step generator, or random voltage generator, depending upon how you connect the inputs to outputs on the same module. This creates a series of very generic designs that really encourage exploration, rewarding the intrepid explorer with new discoveries and a deeper understanding of synthesis. This generic molecular building block design is, in my opinion, the reason why Serge modules are just as fresh and interesting today as they were some 45 years ago. In electronic music, and especially in modular synthesis, there is this emphasis on the new, shiny next thing. It often feels like a new module somehow invalidates a previous version, or that new ideas are unquestionably better than old ones. This is not to say that Serge modules have not iterated since their first designs in the early 70s. They absolutely have. The first generation Paperface modules were the simplest, and things got better through the generations. We went from an oscillator that could not track voltage reliably to the new timbral oscillator, which held stable tuning and could reliably generate pitches within the 12-note Western tuning system we are so accustomed to. It is interesting to follow the line of development, from the positive and negative slew and noise generation modules to the smooth step generator, and finally to the dual universal slope generator that is such a key part of a Serge system. Some manufacturers are using surface mount technology to automate the production and lower the cost and size of Serge modules today. Elby Designs in Australia does a great job of making a line of Euro Serge modules that are less expensive and totally compatible with standard Eurorack systems while still offering banana jacks as an option. But I love the original circuits just as much. There is a ton of room to enjoy all the different generations of Serge modules as legitimate, vibrant, great-sounding music instruments. My system very much reflects this multi-generational approach. I have circuits from the very first of Serge's designs, more modern iterations of his ideas, circuits from other designers like Ken Stone that wanted to round out the analog possibilities within 4U, and 4U ports of digital Eurorack circuits, such as the Turing machine and orgone accumulator. There are truly more directions that you can go in building a Serge system than anyone could possibly have time for. Euroserge. There is no doubt that the Eurorack form factor is ubiquitous throughout the modular community, and several manufacturers have created Serge modules to fit into that ecosystem. If you are committed to Eurorack, then it is great to have the option to add Serge circuits to your existing system. In much the same way that Verbose Electronics brought Buchla to Eurorack, which has recently been followed up by Buchla themselves, both Elby Designs and Random Source make Serge circuits for Eurorack. Since both systems use plus minus 12 volts for power, you should on paper be able to use the same circuitry, making the sound between 4U and 3U more or less identical. In general, the Serge modules are less expensive than their 4U counterparts, so there are a lot of good reasons for exploring that direction. I like the flexibility, size, and greater availability of DIY PCBs in the 4U format personally, but Serge is definitely a viable option to check out. Notable Serge modules. So now that we've had an overview of the system and design philosophy, let's finish up by looking at a few of the classic modules that are so quintessentially Serge. Some of these are variations on modules that you are already familiar with from other systems, but then there are the different modules that really set Serge apart. In keeping with the patch programmability philosophy, they are often very open, generic electronic circuits that can serve a lot of functions depending on how you patch them. We don't have time to do more than just scratch the surface here, but intrepid explorers can find plenty of Serge materials on the internet. There are some Serge-specific websites, as well as YouTube videos that can give you a good start on the topic. 73 Oscillator. Serge's Paperface-era oscillator is fairly simple, but has some interesting features that set it apart. It outputs sine, sawtooth, and wave shapes in between. You can control the wave shape manually or through a control voltage input. It outputs DC for use as a control voltage and AC for audio purposes. There is the variable wave shape output, as well as a dedicated sawtooth out that's really buzzy and harsh. There are two CV inputs for frequency control, a manual frequency control, and a sync input to slave to another oscillator's output. And while there is no dedicated square wave output, you can generate one by running the output into a comparator module. 73 Filter. Serge systems are generally considered as following the West Coast aesthetic, where there is more emphasis on building up overtones using wave shaping, rather than the traditional East Coast subtractive synthesis paradigm. But there are some great filters in the Serge universe nonetheless. In keeping with the Serge paradigm of having access to as many parameters as possible, the 1973 filter has simultaneous low-pass, high-pass, and bandpass outputs, which allows you to split up a signal into various frequency bands. There is voltage control of the cutoff frequency, and a resonance control that can get into self-oscillation territory. It sounds great and is very straightforward to operate. Programmer. The primary original voltage sequencer for the Serge is called the programmer. There is also a module called a sequencer, which is a 10-stage pulse trigger that triggers the next stage every time it receives a clock pulse. But the programmer is the main sequencer. It consists of a master section and an arbitrary number of channels, which can realistically be as many as 14 channels in order for it to fit in a single panel. Each channel has 3 voltage knobs, a pulse in and a pulse out. The master section has voltage outputs for each of the 3 rows of knobs, pulse outputs that trigger each time a new stage is reached, and clock inputs that move the sequencer to the right and to the left. The 3 voltage rows can be used for any synth parameters, such as pitch, filter cutoff, and amplitude. Every time you move to a new stage, a pulse is output from that stage. Each stage also has a pulse input to immediately move the programmer to that stage, as well as a manual button you can press to trigger moving to that given stage immediately. You can adjust the number of stages by sending the pulse output of a stage to the pulse input of a different one. It's all very manual, handled by patching banana cables from inputs to outputs all over the unit. Smooth and step generator. One of my absolute favorite Serge modules is the quirky Smooth and Step Generator. This module has 2 circuits, one of which outputs continuously changing voltage, and the other of which outputs discrete changes in voltage. These circuits can be used separately or in tandem to generate a wide variety of control signals. The smooth generator can be used as a slew limiter to whatever signal is sent into its input, with the rate of slew determined by a rate knob or rate voltage control input. It has a hold input that keeps the output level constant as long as the hold input is set high. It can be used as a triangle LFO and as an audio oscillator when the cycle jack is patched back into the input. The stepped side can work as a sample and hold, a staircase generator, or, when used in conjunction with a noise source, as a random voltage generator. Finally, there is a coupler between the smooth and stepped sides that acts as a comparator. When the stepped side output is higher than the smooth side output, the coupler output goes high. This may all sound like a lot of detail, but the point is that these circuits are very powerful, but require some experimentation to see what they're capable of. Dual Universal Slope Generator. As mentioned, the Make Noise Maths and Bafacco Rampage are both Eurorack designs based on the DUSG. The basic idea is simple. You have a circuit that starts a voltage at one point and ends it at another. And you have two of them in a single module, hence the dual part of the name. But what controls do you have over that change in voltage? You have knobs to control the rise and fall times of the change, and a trigger input to tell it when to perform that function. At this point, we have two attack-release envelopes. But let's add a control voltage to change the rise time, fall time, or both. Now, that envelope can change shape on the fly based on other signals being sent to it. Let's add to the flexibility by adding a crucial output, a pulse that gets sent when the process has completed its journey from the start value to the end value. If you take that pulse out and route it back to the trigger in, you now have a cyclic envelope generator. This can be used as an LFO, but since Serge modules are designed to be high bandwidth, you can move that cycle into the audio range, making the DUSG an oscillator. If you send a complex audio signal into the DUSG's input with a very short rise time and a medium length fall time, you can create an envelope follower, which gives you a control voltage that is analogous to the audio signal you fed into the unit. You can create a pulse delay by feeding a pulse into the input, then adjust the rise and fall times to the delay you want. After the slope is completed, it will send a pulse out of the end cycle jack. Triple wave shaper. Much of the West Coast aesthetic concerns building up timbres from sine waves, rather than filtering harmonically rich waveforms. The triple wave shaper is the quintessential Serge module for adding harmonics to a waveform. The three wave shapers have a progressively stronger effect on the waveform, and ganging the three together, then running the output of the third one back into the input of the first, is a recipe for feedback madness. That is just a brief summary of some of the more notable modules. There are plenty more designed by Serge, and yet more modules created by people like Ken Stone over the years to expand the landscape of this remarkable modular system. So this has been an overview of the Serge modular system, where it came from, what it is made of, and why it is so special. Thank you so much for listening. As always, if you like what we are doing here on Under the Big Tree, please feel free to like, share, and subscribe. For now, this is Nick, signing off.